This is the second in a series of electric weeding research updates from the NIFA OREI funded project Performance and Management of Electric Weeding in Organic Perennial Crops. I'm Alice Formiga of eOrganic at Oregon State University, and today my colleague Linda Brewer and I are talking with Tong Zhen, who is a PhD student at the University of California, Davis in the lab of Brad Hansen. Tong is going to give us an update about his experiments with electric weeding in almond orchards in California.
Thank you so much for having me here. Yeah. And yeah, my name is Tong Jun, and I'm a PhD candidate at University of California, Davis. And we are doing so our lab, Hansen Lab, we are doing the California part of the electrical weed control project. Um, I I'm mostly working with almonds. So like almonds are the largest production in California. So organic almond, there will be like a huge market, like even though it's small right now, but I think there will be a growth in the future. So um applying like non-chemical weed control is a big deal. So that's why it's our goal to help California growers to achieve that goal and to try to reduce herbicide usage. So that's like what I want to do and what I want to help the growers. And like you said, it's just been a 1 year, but I think this in the past year we achieved a lot. Like we just test run the machine, and then we ran several trials, mostly in the almonds orchard, and also I think I also ran another trial in the walnut orchard, but that's for basically like weed control efficacy. And from the preliminary data, I think we can see a pretty like a promising results. And when you compare it to non-treated control, the Zapso machine is really working. So in California, we mostly in orchard we also have like hairy flea bane, like field bindweeds, and especially in my plot, there's lots of like perennial weeds that's so hard to control. For example, like field bindweeds and yellow nut sedge, and field bindweeds are tough to control because it's like it's perennial, and then if you cannot treat the underground part, the rhizome, they're going to grow back anyways. And then like no
Mhm.
matter what kind of herbicide you use,
Mhm.
like in organic, we don't use herbicide at all. So we use tillage. And by using tillage, you are just chopping up those rhizome and they will just regrow like more and more, like increasing the population. But I think we saw a like really promising result from the Zapso treatment. And because the Zapso machine on their website, they were saying like, hey, we can target the underground part because electricity can go through the foliar part and then go deep into the roots, and they can burn the root. I don't have replicated data for
Mhm.
field bindweed, but I have one plot that's like so many field bindweeds, like a carpet on the ground. And then we try to treat them with Zapsol for like I remember it's 4 times in the past growing seasons, and they were just gone, like gone. And then we so last year in June we have our like UC Davis Wheat Day, and we try to demo the machine to the growers. And I told them, hey, we can really like treat bindweeds, and they were so excited, and they, hey, like tell me more, Tong. Like we want to know more. Yeah, so I was really happy about it. But as a scientist, I think I need to have more replicate data to prove that I'm not saying that, hey, it's only one plot. Like we don't know what happened. So I'm going to maybe find like a field that's pretty even distributed field boundaries so we can zap them this year, and then to get some really like meaningful data, so I can say that I can confidently say that, hey, we can treat like field bindweeds with this machine.
That's
And then
great.
also, yeah, I try. So for Yale Nutsedge, I've did a little experiment, but it's not quite successful. So I try to so first we treat the Yale Nutsedge first, and then I dig them up, and then with the roots, I try to cut the cross section of the roots and at different depth, at different length to see how deep the electricity can go. So I
Mhm.
just cut them, chop them off, and then at different depth. and I try to do an observation under microscope, but some like technical issue happen. So we try to use something called like a microtom, like you can cut
Uh-huh.
really thin slices, right?
Yes.
And but like unfortunately we don't have the correct blade, so
Oh,
we
okay.
can cut through the rhizome. Yeah, we try to use like a razor blade to cut it, but
Yeah.
it's not that perfect. So yeah,
Mm.
I hope we can redo that experiment
Mhm.
this year. And so we will have, for example, like if we take up like a yellow nutsedge,
Mhm.
and for those underground parts, I will sample at 5 centimeters, 10 centimeters,
Mhm.
or even between, and then you can
Mhm.
see how
Mhm.
the damage intensity will change
Mhm.
like
Mhm.
along the depth. Yeah, I always talk to like growers. They say, hey, I think this machine can target the underground part, but I don't have confidence to say that because I don't have evidence to show you. But if I have that image, I can say, hey, this is the image. And then, yeah, I don't say no more. And then, yeah, that's it.
Yes,
Yeah.
absolutely.
Yeah. Yeah. So I try to do that like this year and then make sure we have all those like equipment we need. And yeah.
Mhm.
And then in the California part, we also want to try to do more experiment about soil moisture
Mhm.
because in California in the summer is bone dry and then we don't have like
Mhm.
zero rainfall, like zero precipitation. It's
Mhm.
the best place to do like a soil moisture test because in the past experience we figure out if the soil are too wet, it's not good for like its efficacy will decrease. And if the soil are too dry, it will also decrease. So
Mhm.
there should be an optimum like
Mhm.
range of soil moisture level that's like best for the machine. So
Mhm.
we try to like design experiment in California to see what's the best range of moisture, at least in California,
Mhm.
certain type of soil type like and then you can fine tuning the settings, the speed.
Mhm.
The goal for us is to because you know the machine is so powerful, like and
Mhm.
then I my colleague Aliyah from Cornell, she always saying that I think that machine is overkilling the plants.
Ah,
We're using like too much energy that we need.
ah.
So in the perspective of a precision ag, we
Mhm.
think like if we can create a model to see, hey, for this certain like field condition, for this certain soil moisture level, for this certain soil type, what speed, what kind of level we adjust can just deliver the right amount of electricity. We don't need more, but
Mhm.
somehow we need something to like go over the threshold. And if you go underneath the threshold, it's not going to do anything.
Right.
Yeah.
So it sounds like you are developing data that can provide guidance to growers
Yes.
on using enough electricity, but not too much electricity.
Yes, exactly. Because when you use high power, it can just kill everything. But again, you are using so much like fuel, and for if I'm a grower,
Oh.
I would like just use the right amount I need. I don't need that much because it's just wasting all those energy, and it's not good for like it's in a sustainable perspective. It's not good. Yeah. So in the past year, my research focused on like using different speed and power settings for the machine, just to do different treatments. So I try to simplify my treatment name so we don't have those long kind of name. So I try to use like some numbers and letters code. So for example, here on the machine, there are like tabs, 5 tabs you can choose as from 1 to 5. Um, so 5 means like I think it's the lowest power, and then 1 is like high power. But again, like for 1 and 2, for the two highest power, we are not going to use that in the agricultural soil because it's too wet. I think those are for like a row like roadside. I think that's for that. So for us, for Cornell, UC Davis, and Oregon State, we will usually use like from 5 to 3. That's the power setting we are using for the machine. And then for speed, there's some like differences among different places. So I think in Cornell, they try to increase the speed to maybe like something like 5 miles per hour.
Okay.
But we tried it out in our field. It's not working. Like yeah, it's too and then it's the driver have to like control a lot. So I think so for here, because so again, this poster is for the scientific research, so we use metric unit. So in pasture, the highest speed I use is like 2.1 kilometers. It's something about like 1.1 miles per hour.
Correct.
Highest speed we can use, and
Okay.
it's still slow.
So
Yeah.
for our audience, can you confirm that this is correct? The faster the tractor is moving, the lighter, the less rigorous the treatment is. Is that correct?
Yes, because if you can imagine, like if it's just like spraying herbicides, I always have analogies of spraying herbicides because I'm like a research scientist. So if you holding your boom, if you walk faster, the last like droplet on the plant. So that's like less amount of solution into
Okay.
the soil. It's the
Okay.
same idea.
It's the same
Yeah.
principle there, eh?
Yes. Yes.
Thank
Yeah.
you.
Last year I ran like just two trials. So one is the efficacy study, and the other one is the organic like orchard study. It's a crop safety study, and I split into two because for crop safety study, we want to minimize because we only want to see if the machine can damage the almond. So the crop I'm using is almond. We want to see if the machine can damage young almond trees. Like we planted the almond trees last year in April, so it's like they're young, the first leaf almonds, and we want to see if they really damage those young trees. So after every like we ran 4 electrical weed control treatments in a foreign like in the past season. And right after every treatment, I will wait for about like 7 days or 10 days, and then we will just like remove all the weed because those might affect the growth of the trees because like competitions. So we want to minimize those competitions. So we just remove all the weeds. That's why for the weed control data in the crop safety study, we can only have up to like 10 days after treatment. But I don't think it's enough. So that's why we have a separate study to just test on the weed efficacy. That's when I the efficacy study I ran that in a walnut orchard in California. Here's some pictures. So this is like 6 pictures. So the first one is just an overview of the field, and as you can see, you can clearly see which part we use the Zapso and which part we didn't use the Zapso, right? You can see like I even though I use the yellow box, but you can see this like some parts like kind of yellowish. Those are like, yeah, those are really, really damaged. And then the pictures here is untreated plot. I think it's something like, okay, it's 20 days after treatment. So 20 days after treatment, if it's untreated plot, looks like a jungle. We have like this is like I think it's pigweed and mostly hairy flea band. And for the rest of the 4 images, so 583, 483, 581, 481, those are different speed and power combinations. And as you can see, those are like bare ground, bare ground. You can't really see those vegetation over there. And those are only like the one replication. But from the statistic standpoint, among different power and speed settings, they don't have like significant difference. So from the stats standpoint, they don't. There's so many things we can explain that is because maybe like the soil are too wet, the speed like so power 4 and power 5, it's not huge difference like in terms of for example, if you look at the mean amperage. So I'm not a mechanical engineer, so I have limited knowledge about like circuits. But on the machine, there's like a tab you can look at like different amperage and voltage. I use that to compare different power, even though maybe it's not true, but like the differences you can tell. So I record that number. So if you run power 5, usually you will see on the meter you will see 5 amps. So and then if you just use 4, you will see 14, 15 amps. And for reference, 0.1 amps can kill a person. That's for reference. Yeah, that's a lot. But I ran another experiment just 2 days ago. it's early spring, the soil are still wet, and we ran the same power, like power 4, but the amperage can go up to, I think it's 70 amps or to 60 amps. So even though they have the same settings, number can change, depends on how wet your soil is. So there's still a lot of things we can look over and to see what's happening underneath. But from last year experiment, from last year result, we don't think speed and the machine settings are really that important from this study. But I think we need to do more replication. We need to do more study in two different places to test that. Hey, that's not a big deal. Like for speed, like no matter how fast you go, but once you go past a certain like amount of, for example, 4 miles per hour, it's not working at all. But within those 4 miles per hour, 4, 3, 2, maybe it's not a big deal. We don't know yet. But from the result from last year, 1.1 miles per hour is the same with 0.7 miles per hour. Yeah, that's our result. But yeah, there's whole lot of things we can do this year. So I'm pretty excited.
You indicated that you're looking at safety to the crop. Does
Yes.
the electricity harm the tree?
Yeah, I'm gonna show you, like, it's just right here. So again, like so for last year we measure, so to estimate the growth of an almond tree, we usually measure like the height or the tree trunk diameter, like how big they grow. So from those data, there's no difference between untreated plots and the treated plots. So that means no, the Zapso machine is not going to harm the like 1 year old almond trees
Great.
in that settings. Yes.
Okay,
Yeah.
great. How are weeds usually controlled in organic almond orchards?
Mostly like organic herbicide or like tillage. For perennial weeds like vine weeds, yellow nutsedge, it's just limited control on those weeds because it's not systemic herbicide. It's not like glyphosate. You can like really like target, like they can translocate and then damage the cells.
Mhm.
No, it's not. So most organic herbicide, they're just contact herbicide. But again, so this machine, if it really can damage the underground part, that means we can control perennial weeds, and also we can also maybe control grasses, because I think for grasses in organic, they use mow every month. That's not very effective because for grasses, the growing point of the grass is like right one inch or like 1 centimeter right above the soil. And
Right.
for mowing, you're not going to damage that part. And if you're not going to damage that part, it will grow back anyways. That's why you need to mow them every month
Mhm.
or so.
Mhm.
Yeah.
Mhm.
So, but if
Um,
this machine can damage
mhm.
that growing point, that's a good
Mhm.
that's
Well,
Very
it sounds like
interesting.
in the next year you'll be getting more precise data on exactly how much damage is done below the soil.
yes,
Mm.
Yeah,
yes.
This
well,
is very nice work.
yeah,
Thank you.
it's great to talk to you and
Thank
learn
you.
more from the graduate students who are there on the ground.
Mhm.
Thank you so much, Tong,
You.
for taking the time to do this interview on the spot.
Thank you so much for having me here. Yeah, yeah.
Well, there's a lot of interest among growers, organic and conventional, in this equipment. And so having you to talk about your field experience, that's information that the farmers want. So thank you.